Can you see my slide?
Yes, madam.
Can you see my slide?
Yes, madam.
Okay. Okay. Good evening, everyone. First of all, I would like to thank National Building Council for giving me this opportunity. During this session, I'm going to talk about a very important topic, that is industrial wastewater. I think this talk will be helpful for school students, undergraduate students, general public, and all other participants to gain some understanding of industrial wastewater and strategies that can be implemented to minimize these effects. Okay, so first of all, we need to consider about this. Do you know that every year industries around the world release over 400 million tons of pollutants like heavy metals, solvents, toxic sludge, and various other harmful substances into our natural water bodies? This is not just a number, it's a serious threat to our environment and public health. Because of that, wastewater management is very important. So during this talk, let's take a close attention at industrial water pollution, environmental consequences, and clean water solutions. Okay. Before talking about industrial wastewater, we need to focus on very important incident, that is industrial revolution. That is an undesirable change in physical, chemical, and biological characteristics of our air, land, and water. Why? What is the reason for that? That is the period transition from manual labor to mechanized and factorized based production. This is begun in Britain in 18th century. After that, it spread to other parts of the world. So, due to this industrial revolution, contaminants are released into the environment rapidly than before. Industrial wastewater is one of the major sources contributing to water pollution today. Here you can see different types of industries. Different industries generates different types of wastewater, each containing a unique mix of contaminants. For an examples, I have mentioned some examples here, examples for some industries, textile factories, food processing plants, chemical industries, all produce very different kinds of effluent. Because of this variation, industrial wastewater is not something we can treat with one approach. The treatment method need to be carefully designed considering the specific types of pollutants found in each industrial wastewater. So, understanding the source and the composition of the wastewater is the first step towards effectively managing this wastewater. As mentioned previously, here you can see the difference in the types of the pollutants with the type of the industry and the pollutant. Especially when we are talking about iron and steel industry, you can see the pollutants. Chemical industry, you can see the pollutants types. These are not all pollutant types, but here I have mentioned about major pollutants from these industries. I'm sure many of you have seen water bodies like this, where the surface is covered with a greenish layer. You might have wondered, what is that? Okay, those are algal blooms. So, to grow rapidly like that, in this way, they need the right condition. What are those right conditions? Right conditions are sunlight and nutrients. When industrial wastewater is released into the water bodies, especially if rich in nitrates and phosphate, it creates a perfect environment for these algal populations. This can lead to excessive algal growth, which we call eutrophication. That is the process here, eutrophication. And it has serious impact on the aquatic life and the water quality. Now, after these algal blooms die, they don't just disappear. They sink to the bottom of the lake, and that's where microorganisms start breaking them down. This is especially by aerobic bacteria. During this process, they use dissolved oxygen in the water. For the degradation, microorganisms are using dissolved oxygen. As more algal population decompose, more oxygen gas is consumed by dissolved oxygen. Here, dissolved oxygen is consumed by this microorganism, and the oxygen level in the water is starting to drop significantly. Ultimately, the environment becomes anoxic. Anoxic means oxygen-free environment. There is little to no oxygen. At this stage, when there is no oxygen in this water, anaerobic microorganisms, these anaerobic microorganisms are growing under anoxic conditions, are starting the decomposition process. And during this decomposition process by these anaerobic bacteria, they release gases like hydrogen sulfide. That is having a strong, unpleasant smell like rotten eggs. I'm sure many of you have noticed this odor around areas like Berry Weber. I'm sure about that. That smell is a clear indicator of anaerobic conditions and poor water quality. That is a sign that the ecosystem is under stress. On the other hand, this lack of oxygen is very harmful to aquatic life, especially for fish and other organisms that depending on oxygen. Now, in addition to nutrients like nitrate and phosphates, industrial wastewater can also contain some highly dangerous substances. First, in here, we have heavy metals. Heavy metals such as mercury, lead, cadmium, and arsenic. These metals don't break down easily and can accumulate in the food chain over time, reaching human through fish and other aquatic life. Next are toxic organic pollutants. Things like pesticides, industrial solvents, and petrochemicals. These can cause serious health problems including cancer, hormone disruptions, and neurological diseases. And finally, in some cases, industrial effluents may also contain pathogenic microorganisms. Disease causing bacteria like Vibrio cholera and also Salmonella typhus, viruses like hepatitis or parasites. Okay. When these enter our water bodies, they pose as a direct threat to public health, especially in communities that rely on these sources for drinking and bathing purposes. These heavy metals and pathogenic microorganisms not only contribute to human diseases and even deaths, but they also have a broader impact beyond health. They affect the country's economy by increasing healthcare costs, raising the expenses for wastewater treatment, and even causing a decline in tourism, especially in areas where water bodies are polluted or unsafe. According to the International Union for Conservation of Nature, that is IUCN. You all know about this IUCN. According to IUCN Red List, there are around 27,400 freshwater species globally. Many of these species completely depend on clean and healthy freshwater ecosystem. Now, as you can see in this slide, this is the proportion of freshwater species by threat category across different regions. So the question is, what happens when our water bodies are polluted with industrial wastewater? These species are placed under serious risk as this aquatic population, aquatic organisms are under risk due to this wastewater pollution. This is inhibiting the activities of these aquatic organisms and also poisoning their food sources, and also that can be a cause for the extinction of this aquatic organism. To control these harmful discharges and to protect not just the environment but also human health and the economy, there must be strong legislative frameworks. Laws and regulations are essential to monitor, manage, and minimize industrial wastewater pollution. Considering the rapid advancement in industrial technologies and evolving environmental needs, several amendments have been made to existing regulation over time, starting from as far back as 1980. One key step was taken under the National Environmental Act number 53 in 2000, which identified specific industrial activities that require environmental protection license. But even that was not enough, so the act was further amended in 2008 and again in 2022 to keep up with changing industrial practices. Under environmental laws, certain industries need to follow key steps like getting an environmental protection license if their activities could seriously affect the environment as outlined in this gazette number 2264. If they deal with hazardous waste, they must have a scheduled waste management license. And for large developing projects, an environmental impact assessment has to be done before starting these industries. So these are based on the guidelines in the relevant gazettes. Effluent monitoring and industrial inspections play an important role in controlling industrial water pollution. When it comes to enforcement, high and medium pollutant industries are monitored by Central Environmental Authority. Low pollutant industries are monitored by local government authorities. And also, regular inspections are conducted. For high polluting industries, the environmental protection license is issued for a maximum of 1 year and inspections are done twice a year. For medium pollutant industries, inspections are carried out once a year. In addition to that, industries are required to submit self-monitoring reports. These reports must include results from Central Environmental Authority registered laboratories as well as one report from Central Environmental Authority online. High pollutant industries must submit a report on a quarterly basis, while medium pollutants ones submit their reports biannually or annually depending on the risk level. These systems ensure that industries are kept within the safe limits. Here you can see the tolerance limit values for inland water discharges. These values are taken from the BOI zone in Biagam, especially from the common wastewater treatment plant. These limits are set to ensure environmental safety standards and minimize harm to environment and human health. So, to ensure safety, industries must treat their wastewater before discharging it into natural waterways. When we look at a general wastewater treatment plant, it is with four main stages: primary treatment, and primary treatment, secondary treatment, and also tertiary treatment. As we move from the preliminary stage to the tertiary stage, both the complexity and the cost of the treatment processes increasing. Preliminary treatment involves basic physical processes like screening and grit removal. Primary and secondary treatment focuses more on settling solids and biological treatments. And tertiary treatment is used when very high water purity is needed. This is depending on the type of the industry. Now, let's talk about the techniques used in the preliminary treatment stage. These include bar screening, grit removal, fat and grease removal. Here you can see an image of a bar screening unit. Here, this is a picture of a bar screening unit. It's one of the simplest engineering processes in wastewater treatment, but a very important one. Bar screening are placed at the very beginning of the treatment plant. Uh, the job of this bar screening is to remove large solid materials like pieces of wood, plastics that could damage or block pumps and other equipment in this wastewater treatment plant. And this step protects the rest of the treatment system. This is a grit chamber, which is used in a preliminary treatment stage to remove grit from wastewater. Just like bar screening, grit removal is essential because if these particles are not removed, they can cause serious damage to pumps, pipelines, and other mechanical parts in the treatment plant. Grits include unwanted materials like sands, gravel, some stones, and other heavy particles that have a higher specific gravity than the organic matter in this wastewater stream. Next, primary treatment stage. This involves the use of sedimentation tank. In many industries, this stage also includes skimmers to remove fat, oil and grease from the surface of the water. Here in this picture, you can see a skimmer working on the surface of the sedimentation tank. Okay. During primary treatment, the wastewater is kept in the sedimentation tank for a few hours, normally between 1.5 to 2.5 hours to settle down the suspended solid. Okay, now we are talking about primary treatment. A well-designed and properly operated sedimentation tank can remove about 25% to 40% of BOD. BOD means biological oxygen demand, that is indicating the organic content in water. And also around 50 to 70% of suspended solids. And also we need to mention, to improve the removal of solids, industries usually add flocculant or polymers to sedimentation tanks. Here you can see different types of sedimentation tanks: oblong horizontal sedimentation tanks and cylindrical horizontal sedimentation tanks, that is depending on the shape of the sedimentation tank. After the primary treatment, we discuss about preliminary treatment and the primary treatment. These are very simple techniques. After the primary treatment, the water moves to the secondary treatment stage. This is a biological treatment process. In previous stages, we didn't use biological treatment processes. In this stage, we are using biological treatment processes. The main objective of this secondary treatment is to reduce biological oxygen demand. That is meaning of that is reduce the organic content in water. In industrial wastewater, the BOD level is very high, often around 1500 milligrams per liter. Through secondary treatment, this is brought down significantly, usually to the range of 5 to 30 milligrams per liter. The secondary treatment takes place in two main environments. Those two environments are aerobic condition and anaerobic condition. Aerobic conditions mean oxygen available conditions. Anaerobic conditions mean oxygen unavailable condition. This type of environment has a significant impact on the treatment process. It affects three key aspects such as the efficiency of the biological treatment, end products, and the completeness of breaking down of organic matter. So choosing the right environment is important depending on the treatment goals and the nature of the wastewater. When we talk about aerobic conditions and secondary treatment, in this session I am mainly focused on aerobic conditions under the secondary treatment. Okay, there are two main types: system, attached culture system, and suspended culture systems. In attached culture system, the biomass grow on a surface of a medium or inside the medium, and the sewage flow over it. Two more common examples for these attached culture systems are trickling filters and rotating biological contactors. Next one is suspended culture system. In here, the biomass is mixed directly with the wastewater. Common examples are activated sludge system and oxidation ditch. Each system has its own advantages depending on the design and the treatment goals. In this video, you can see a trickling filter. That is an attached culture system. The rotating arms are sprinkling wastewater evenly over this bed. This is especially with stone media. This is non-toxic media for microorganisms. Microorganisms grow on the surface and inside this material. Okay, you can see a cross section of this trickling filter here. As the wastewater passing over it, biological degradation of the organic matter is happening. Next, rotating biological reactor. This is the second example for attached culture system. In this system, microorganisms also grow on the surface and inside the rotating disc. Here, industrial waste management systems are using, the people are using disc in these rotating biological reactors. These discs are partially submerged in water, usually about 40%. When the disc is rotating, the biofilm means the microorganisms inside this disc on the surface, especially in the surface of this disk, come into the contact with both the wastewater and the atmosphere. When they are coming to the atmosphere, they can obtain oxygen. So far, we have been discussing the attached culture system. Attached culture system, we discuss about trickling filter and rotating biological reactor. In contrast, this attached culture system, in suspended culture system, the wastewater is fully mixed with the microorganism. There's a mixing of microorganisms and the wastewater. This allows for better contact between the organic matter and the microbes. And this is enhancing the efficiency of the treatment process. Here we can obtain 90 to 95% BOD reduction. This is activated sludge process. Okay. So according to the suspended culture system, there are two examples: activated sludge system and oxidation ditch. This is the first example, activated sludge process. Here there are two processes, aeration basing and the secondary clarifier. In this picture, you can see that aeration basing and the secondary clarifier. In the activated sludge system, some of the activated sludge is returned to the aeration tank. This keeps a strong population of activated microbes in the tank that ready to break down organic pollutants very effectively. Okay, in this picture you can see activated sludge return into the aeration tank. Okay, this activated sludge is from the secondary clarifier. Here you can see aeration tank, secondary clarifier, primary effluents, and return sludge is mixing and forming mixed liquor suspended solid. After the secondary clarification, we obtain a clear looking solution. Like this, we can obtain clear looking solution. However, even though it appears clear, it is important to verify its quantity through laboratory analysis before releasing into the natural waterways. This is to ensure that it meets regulatory guidelines for environmental safety. Okay, that is the reason for that. If needed, we can also proceed with tertiary treatment to further polish this effluent. This is an oxidation ditch. This is the second example for suspended culture system. Oxidation ditch is a special type of activated sludge system used in biological wastewater treatment. When considered about the retention time that is comparatively high, uh, retention time, this is having a very comparatively high retention time. This is enhanced in the removal of biodegradable organic matter. In this system, the only pre-treatment usually used is a bar screen. After that, the wastewater flow directly into the oxidation ditch. Here you can see a video of an oxidation ditch. The ditch is a circular oval shaped basin. For the biological degradation of organic compound in wastewater, the activated sludge is added to this. Sorry, when you are talking about this oxidation ditch, this active oxidation ditch retention time is higher than other aeration basins. Okay, so we can reduce the BOD content in water for a higher extent using this oxidation ditch. You can see the flow of this water in this oxidation ditch system. During this flow moving of the water, the organic content in this wastewater can be reduced. Because of that, we can reduce the BOD content. BOD content means biological oxygen demand. Before the treated water is released into the maturation pond, it often undergoes chlorination. This helps to remove any remaining pathogenic microorganisms in this water. So, what is this maturation pond? What is this maturation pond? So, here you can see a photo of a maturation pond. Maturation pond is the final stage in wastewater treatment. Here is the place where that water is going through natural purification through sunlight, microbial activities, and sedimentation processes. This is normally consisted with two reservoirs with 2-day retention time, and also this is used to remove pathogenic microorganisms and remaining nutrients in this wastewater. And also, especially phytoremediation is also playing a significant role here because plants help to absorb and break down pollutants in water. After these treatments, the clean water is released into natural waterways through a canal system. Usually, the water that's discharged after treatment is actually better in quality. But if the treated water doesn't meet the required standards, it has to undergo tertiary treatment. Before the water is sent to the maturation point, it is tested in a laboratory. Based on those results, we can decide the need for the tertiary treatment. In this picture, you can see some water samples that taken for the analysis in Biagama BOI zone common wastewater treatment plant. Tertiary treatment is the final polishing step in the wastewater treatment process. It takes place after secondary treatment and uses chemicals or physiochemical methods to further reduce BOD, bacteria, suspended solids, toxic substances, and nutrients in treated water. This step becomes especially important when we need a high quality effluent. Okay, that is depending on the final usage. Here you can see few examples of physiochemical methods used in tertiary treatment. These methods are more complex and more expensive than other treatment techniques. Okay, so these are the examples for tertiary treatment techniques. Okay. I am receiving some messages. Okay. In wastewater treatment, tertiary processes use advanced technologies to achieve higher water quality standards. Some examples of these advanced technologies include membrane filtration, UV disinfection, activated carbon adsorption, and advanced oxidation processes. And also we can call this as AOP. Each of these plays a key role in ensuring the treated water is clean, safe, and suitable for discharge into natural waterways, because we need to worry about this quality of the water because we are releasing this wastewater into natural waterways. So this is membrane filtration. There are four main types. They are classified based on the size of the particles they remove from the water. Let's talk about these filtration techniques. First one is RO filtration. You always know about this technique, RO filtration, that gives the finest filtration. Next one is nano filtration, allows small ions but blocks organic compounds. Ultrafiltration, it blocks larger molecules like proteins, fats, and polysaccharides. Next one is microfiltration, largest pore size among the four types is having a largest pore size among all four types. It's mainly used to remove suspended solids, bacteria, and fat globules. Next advanced technology is UV light, UV disinfection. This is now widely used as an effective and eco-friendly method to disinfect wastewater. Through this, we can inactivate harmful microorganisms without chemical treatment processes. This disinfection process doesn't add anything to our water, doesn't change its chemical makeup or oxygen levels, and doesn't produce any harmful disinfections byproducts. So this is very important disinfection technique. One important advantage of UV disinfection of chlorine is its ability to inactivate chlorine-resistant protozoa. These organisms that pose significant risk to public health but could not eliminate with chlorine treatment. Next, activated carbon adsorption. Now we are going to talk about on this activated carbon adsorption. Activated carbon is a highly porous material, which means it has huge surface area that can adsorb, not absorb, adsorbing is here. Various pollutants we can, using this porous material, we can remove pollutant by the process of adsorption. It is ideal for removing organic pollutants, heavy metals, and pharmaceutical products from our wastewater. Now, this is a powerful tool in advanced wastewater treatment. Many researchers do many research activities regarding this activated carbon for toxic removals and some pollutant removal. And also, advanced oxidation process can be used to remove contaminants in water. These processes involve oxidants and UV light combination to degrade complex organic pollutants to non-toxic and simple compounds. There are two main types: hydroxyl radical-based advanced oxidation processes and sulfate radical-based advanced oxidation processes. Advanced oxidation processes, or these AOPs, first introduced in 1980 mainly for potable water treatment. That is for potable water treatment, not for wastewater treatment. These processes use very powerful oxidizing agents, especially hydroxyl or sulfate radicals, to break down contaminants in water. Later on, these AOPs became widely used in wastewater treatment because these strong radicals can effectively remove some pollutants that could not handle by other methods. In the 1990s, advanced oxidation processes were first used to treat landfill leachate, which is one of the most challenging type of wastewater. Here you can see a sanitary landfill. According to their system, they need to collect leachate from this sanitary landfill. So they are consistent, this leachate is consisted with different types of hazardous pollutants. So using these advanced oxidation processes, we can remove these pollutants in this leachate. So this is the end of today's talk. Okay, we talk about cleaner water solution strategies and also consequences of this water pollution, and also we talk about some advanced technologies that can be implemented to remove pollutants in water. So when we talk about this concept, clean water solution is require a combination of technology, awareness, and responsibility. Not only technology, not only responsibility, not only the awareness, we need combination of these all factors. Clean water is not just a resource, that is a right, okay? That is not just a resource, that is a right. With innovative treatment techniques and a strong commitment to the sustainability, we can protect our water for future generation. Okay, thank you very much. Let's be the change towards cleaner water and a healthier planet. Thank you very much again.
Thank you, Dr. Tharani Fernando, Madam, for such an enlightening presentation. Now it's perfect time to engage with our audience. If you have any questions, please feel free to type them in the chat box or raise your hands to ask.
Uh, Good evening. Hello. Hello.
Good evening.
Dr. Tharini, can I ask some that can you suggest some that low-cost, simple method to treat the wastewater we generate from the coir industry, because it's a huge problem. The coir industry wastewater is contain high electrical conductivity. That's why that coir mill owners are not they are not that much that.
Can you repeat that? Can you repeat your
can you
question?
suggest some low-cost, simple method to treat the wastewater which generate from the coir industry because it's contain the higher electrical conductivity.
High
It will,
electrical conductivity, no? High
yes, yes.
electrical conductivity means that is contained consisted with a high amount of ions in your
Yes,
water.
yes, because it's
Yes,
contain coir. They are normally that soaking the coir husk in the water, and after that they are doing their that natural process of producing coir or coconut chip, that coir chips. That when they are releasing the water into the lands, that they are not treating, just they are diluting 1 to 8 diluting or something. That long time issue is the that when that electrical conductivity high water content in the normal soil, it will reduce the soil fertility when it take the long time process.
yes,
So
I
can you
think
some, yes,
I have some suggestion for that. You can use activated carbon,
but
especially
it's high cost, no.
yes, activated carbon for you. You
Yes,
need
that there's a, yes, there's a research from that University of Vavuniya. The student has taken that research.
yes,
She has done it collaborated with the CEA. She has used the charcoal from the sawdust and the Japan jabra, like various floral materials.
yes.
But it's not success like then activated carbon.
Yes,
That's the
in my
problem.
research, I have done studies on Igni activated carbon. I think you have heard about Igni. Igni seeds,
Yes, yes, I
yes.
know, yes.
Igni seeds, that is a very porous material. When it's become to the activated carbon, the porosity is increasing higher. That's higher amount.
That's the problem is when we are talk about the commercial level, is
Yes,
it practical?
yes. Commercial level, you need to go for some cost-effective method. No.
Yes, that's right. In Sri Lanka,
Yes,
there's a many research, but they are not commercial. That's the
yes,
problem. We are talking about the commercial level industry because that Sri Lanka, they are having many industry in coir industry. They face lot of problem with that wastewater generate from that industry. They cannot treat. It's high cost. That's a problem. The farmers cannot achieve that high cost.
yes. Actually, when we are
That's
talking
the
about these seeds, these are very low cost seeds. Sri Lanka, in India, also in many countries, this is growing in natural way. Because of that, when we are considering about the
but
cost,
availability. But availability, is it available? More available in Sri Lanka? In
yes,
Guinea?
it is available in Sri Lanka. Yes,
To create the commercial level coir husk in Sri Lanka, all the that coir industry. I
sorry,
don't. Is it practical in commercial level?
sorry.
I don't think it's practical in commercial level because there are huge industry in Kurunagal, in Anuradhapura. There are huge industry in the coir industry.
Yes, you are thinking about the quantity of these materials. No.
Yes, that's a problem. Yes. And
Yes.
also, I have another question that can we can Doctor, can you suggest any practical solution for batik industry? Not that commercial level, it's a cottage level because it's must to take environment protection license to license
Mhm.
according to 226 64 gazette notification. They have to take any other labels more than four labels. If the batik industry content, they have to take the license. And also there's a requirement of take the wastewater report from the batik industry. But in Sri Lanka, there is no any simple method to treat the wastewater generated from the batik industry for the cottage level. Can you suggest or can you do the research in your university level to treat that batik wastewater? Or do you have any suggestion? Hello?
Can you hear me?
Yes,
Okay.
I
Batik means especially those are dyes, no?
yes.
Batik industry is okay. I have done a research on this batik, sorry, waste. methylene blue, that is a
Yes,
dye.
yes, yes,
I I used encapsulated activated carbon, that is encapsulated activated carbon for removing this dye material from water. Those are, when we are considering about the cost is high. That is
yes,
my research cost above because we are encapsulating these materials using chitosan. Chitosan is a very high expensive material. However,
yes,
we can produce this chitosan locally. If we can produce this chitosan, that is cost effective. If we are going to purchase this chitosan, that is not cost effective. That is the problem with these encapsulated materials. Encapsulated materials are very effective but that is very expensive.
yes.
Yes.
That's the problem. That commercial level and cottage level, it's a practical. There's a practical issue in Sri Lanka. They can.
How about coconut rusk activate coconut based activated carbon? Did you check this with your with the
That student, I think that student has done that research regarding the coconut charcoal also. But the
for
problem,
bathing?
yes, but the problem is it's not really effective when we compare with the activated carbon. That's the
Normally,
problem. Yes.
normally we are doing research, especially on this dye. When we are doing these types of research, the reduction percentage is 98% using especially using this activated carbon.
Yes, yes, I know that the problem is that when we are talking about the batik industry level, the
Yes,
in that batik industry people, they have to do that huge amount of wastewater the one time they have to treat.
yes.
That's the problem. That I also talk with them to that sand filter system when we
And
talk
also
about
you can use phytoremediation techniques.
phytoremediation. Okay.
Phytoremediation
Check with
techniques.
that. There's no any that specific treatment system in Sri Lanka. Is there any specific treatment system in Sri Lanka?
In
Can
this,
we, yes,
sorry,
is there any specific treatment system that we can purchase or something? Or can we that suggest for
specific
that
for
people?
two types of industries. No, we need to contact a Central Environmental Authority for this purpose. They can advise regarding this waste treatment techniques, especially for your industries. They have categorized industries based on the levels, no, high, medium, and low, uh, because your industry type is different from other industries. No, there are some specific treatment techniques for specialized for your products. Because of that, you can contact Central Environmental Authority to consider to know about any specific treatments for this batik and your other part of industry.
Okay, okay, thank you, Doctor.
Didn't you contact with Central Environmental Authority?
The problem is I'm from Central Environmental Authority. We have the problem. We have the commercialized level for the commercial level, but cottage level there's nothing in Sri Lanka. We also face that problem. That's why I asked
Yeah.
if you have any research, we can contact the
Mm.
industry people with the university, and they can have the advice from you. That's why I ask. The
Yes,
cottage level there's nothing. The commercial level they are huge. There are many, but the cottage level there are nothing in Sri Lanka. They cannot bear the high cost, the complex one, because their economy is very low. They just start the industry, but they have to take the wastewater treatment, the wastewater report, and they have to take the EPL. That's a problem.
yes. According to my
Yes.
experience, this is a small type of industry, According to my experience, I know household you can use some conditions like phytoremediation processes and also activated charcoal. Activated charcoal, especially as you mentioned, you need to use cost-effective materials such as a coconut husk. So you didn't obtain good results from that. That is the problem. We need to check your wastewater in our laboratories. After that, we can get some idea about the reduction levels.
Okay. Doctor, can we have the advice or the awareness program with your university and with you for that industrial people if we
Yes, you
arrange
can.
something? Okay.
Yes,
Okay. Thank you, Doctor. Thank you very much.
thank you.
Yes, yes. This is a very serious problem because for the most of the industries, we do not have uh, wastewater treatment facilities because of the cost, and there are no methods available also. Even for the hospital wastewater treatment, laboratory wastewater treatment, there's a big issue. I think we need further research and development of low-cost, affordable methods. Otherwise, this has been there for a long time, and a lot of issues are there.
Yes, yes, most of very high amount of studies have been conducted by researchers, but all the studies are based on the laboratory scales, not going to for the large scales and industrial scale. That is the main problem behind these research activities. We need to resolve this problem.
Yes, even that's why even the hospitals and the laboratories are facing a huge problem. Even the university laboratories do not
Yes,
have
yes, that is
wastewater treatment facilities.
yes, that is the main problem. Okay, have you any questions?
If at least one university can have a pilot system available, then the others can learn from it. But none of the universities have a proper wastewater treatment systems. So for the laboratories, that also just seeps into the earth and a lot of
Yes.
problems.
That is affecting for our groundwater quality. That's a serious issue. Thank you very much.
Doctor, since we have talked about the hospital wastewater treatment, what are the basic treatment processes for hazardous water generated in the hazardous wastewater generated in the hospitals? Yeah, practice in Sri Lanka.
Have you any questions? Can you hear me? Have you any questions? Tanura, have you any question?
Yes, madam. Am I audible enough?
Yes, yes.
I raised the question earlier. Since we have talked about the hospital wastewater management,
Yes.
what are the practices in Sri Lanka to treat hazardous wastewater generated in the hospital?
Hazardous wastewater generation, especially some activities are conducted in hospitals. Okay, so when consider about this, that is at the minimum level. That is especially when we are talking about solid waste, especially in the solid waste. Okay, now I'm not talking about this wastewater generated from these hospitals. Is for the solid waste they are using incineration activities. For the wastewater, especially, I need to tell that some lack of treatment techniques in this concern, especially regarding the wastewater. However, solid waste management is okay. Solid waste management is done by incineration activities. That is the main technique for the solid waste. For the treatment of the waste water, we can use simple techniques like uh, preliminary, primary, and also we can use secondary treatments. Okay, especially using the secondary treatment, we can remove different types of pollutants. It's not especially not only organic pollutants. Okay, here in this presentation I discuss only about aerobic conditions. Okay, only about aerobic conditions, and the anaerobic conditions we can reduce the pollutant levels in this wastewater up to some extent. Okay, so using these types of techniques we can reduce the pollutants in this water. However, sir, when considering about hazardous waste, when we take blood from the patient, we need to keep these in a container, and we need to um, transfer this solid waste to the incineration plants, and we need to do incineration process for this hazardous waste. Is this clear,
No,
or you need
Yes, madam. Yeah,
explanations?
that
yeah.
means we can't mix the hazardous wastewater with the general wastewater in the hospital, right?
Yeah, now normally what happens is in the hospitals, they use sodium hypochlorite to even the blood products to disinfect. That is the main agent that they use. And also they use lime beds for neutralization of wastewater. That is also at the minimum level.
Are they
And
not
once it is
using chlorination activities, especially chlorination?
chlorination, that is for the sewerage systems. They have sewerage plants, and most of the sewerage plants are very old and the capacity is not sufficient, and the repairs are going on at the moment. And after the sewerage treatment, the chlorination happens.
Thank you very much.
And also besides incineration, steam sterilization also takes place in hospitals for treatment of medical infectious waste.
For the solid waste, okay.
Okay, thank you very much for the explanation.
Thank you, madam. On behalf of the Green Building Council of Sri Lanka, I extend our heartfelt gratitude to Dr. Tharani Fernando for sharing her time, knowledge, and invaluable expertise with
मैं
us.
धनुष का लिंक टिकट ज्वाइन कर बा
Audience, thank you for your active participation and engagement. Your enthusiasm and curiosity make a session like this impactful and meaningful. We look forward to seeing
फील कर
you
लाइवर आइबा
again at our next Screen Talk session, where we continue our journey towards sustainability and environmental stewardship. Until then, stay safe, stay inspired, and let's work together to build a greener, more resilient future. Good night. Thank you.
Thank you very much.